Good morning, students. Today, the topic is conservation of momentum. Wait, conservation of momentum. Okay, momentum that is motion contained in a moving body. Okay, that is called momentum, and conservation means when the body accelerates, means when body changes its momentum, then initial momentum will be equal to the final momentum, means momentum will be conserved. That is called conservation of momentum. Now with the help of some example, with the help of an example, just we are going to discuss about this topic, conservation of momentum. Suppose two objects or two balls a and B of masses A and of masses MA and MB are traveling in the same direction along a straight line at different velocity UA and UB. Okay, you see, wait, yes. Suppose two objects, two ball A and B. Suppose they are two balls. This is ball A and this is ball B, having mass MA and MB, means its mass is MA and its mass is MB. Okay, and this ball is moving with velocity u1 because this is initial velocity, and this velocity moving with velocity ua. You can also write ua and ub. Okay, then they are moving in the same direction, and one more point is there, ua is greater than ub. So this ball, this red ball speed is more than this b ball. Okay, so they will collide, and when they collide, then they change their velocity, so momentum will also be changed. Okay, now you see, there are the two balls having mass ma MB, velocity UA and UB. After the collision, when they collide, okay, then the ball A exert force on ball B, mean this ball exert force on this ball, and same this ball exert force on this ball. Okay, and both the forces are equal but in opposite direction. Now you see, when they collide, then they change their velocity. You can see here. Now the velocities of both the objects is changed, VA and VB. So momentum also changed because the momentum formula, that is MV or MU. Okay. So from equation 9.1, the momenta is plural word. Okay, and momentum is singular. Both are same. Momentum of ball A before and after the collision. This momentum of ball before and after collision. Momentum of ball A before collision, this is MAUA, and after collision MAVA, because this velocity change UA to VA, means initial velocity U and final velocity V. When they collide, then momentum will change because of this velocity. So here it is written MAUA and MAVA because velocity change, mass will be same. Now the rate of change of momentum during the collision will be the rate of change of momentum. Rate means upon time, and change of momentum is MAVA minus MAUA. Okay, you can also write MAVA minus MAUA. This is final momentum minus initial momentum upon time. So you keep in mind, this is momentum. Okay, now this is momentum for ball A, and this is momentum for ball B, same. Okay, now according to third law, ball A applies force on object ball B, and in return the ball B applies force on ball A, but in opposite direction. You see here, forces are equal, so the formula of force, that is rate of change of momentum. Okay, force is directly proportional to the rate of change of momentum. So this is the rate of change of momentum of ball A, and this will be ball B. Okay, when you solve it, then cancel t to t, then it will come like MA UA minus MA VA, like this. Okay, or simply I just tell you, if you cut it, then you solve it like MA VA minus MA UA is equal to minus MB VB minus minus plus MB UB. Then you bring this to this, you bring this side. Okay, then it become MAVA plus MAVB MAUA plus MAMBUB. This is initial momentum. Okay, and this is final momentum. They both are equal, so this is called conservation of momentum. Since MAUA plus MBUB is the total momentum of the ball before the collision and after the collision, so total momentum after the collision will be conserved. We observe that the total momentum of the two balls remain unchanged or conserved provided no other external force act. Okay, this is important point. This should you include your definition in your definition. Okay, this is not so difficult. Okay, you can start from here also. The force are equal. Okay, then you just use the formula of force, that is ma. Mass is same and acceleration v minus u upon t, like this. Okay, you are talking about object A, ball A, then you write AA. Okay, then similarly minus this. Okay, then you can see it. So as a result of this ideal collision experiment, we say that the sum of momenta of the two objects before collision is equal to the sum of momenta after the collision, provided there is no external imbalance force. That is important. Okay, this is known as the law of conservation of momentum. It's clear? Now activity 9.1. Take a rubber balloon, inflate it fully, tie its neck usually using a thread, also using adhesive tape, fix a straw on the surface of the balloon. You see here, you take a balloon, okay, you tie its neck with the help of thread, and with the help of tape or some adhesive you just attach a straw here. Then from the next point you just pass a thread in this straw like this. Okay, understood? Now remove the thread tied on the neck of balloon. You remove the thread, the air escape in this direction, and observe the direction in which straw moves. Straw moves in this direction. Means this is action and reaction force. Okay, this is action and reaction force. Okay. Also you can call this this is the conservation of momentum, because it applies the third law of motion. Conservation of momentum applies the third law of motion. Now activity 9.6. Take a test tube of good quality glass material and put a small amount of water in it. Place a stop cork at the mouth of it. You see here, you take a test tube and you just put water inside it. Then by using cork, okay, you just tie it. Then heat the test tube with a burner until water vaporizes and cork blows out. When you heat it, then what happens? The water start evaporating and exert a force in this cork. Then the cork move out. Okay. Now you observe that the test tube recoil in the direction opposite to the direction of cork. Now you will see this is the direction of cork. Cork move in this direction and the test tube move in this direction. So this is also the third law of motion. Okay. Now this is clear. Now example 9.6. How many examples? 9.7. Okay, Okay, 9.8 also. Okay, now these three examples na, or maybe these three questions we will discuss in the next video. Okay, this is all about the conservation of momentum. Thank you.